Hey guys, it's Preston Wallace here, and today we are going to be searching through a graph. Now we're not going to be constructing a graph, we're just going to be searching through to see if a path exists in a graph. So for example, we are right here, we have does path exist passing in the graph. From A to B, of course there is one. From B to A, no there isn't because it's only one directional. And then say A to D, you see we go through B to get to D, so there is a path there. So let's just check this out. All right, so first of all, we're going to create our function. Does path exist? We're going to be passing in our graph and our start and our target. All right, so first of all, we want to check and see if this actually exists in the graph. So if we don't have anything in graph at start, then we want to just immediately return false. Otherwise, we want to return the value of the true or false value of going over all of these vertices. So basically graph at start is going to be, say in this case, graph at A is going to be this array B. So it's an array, graph at start dot sum, and what sum does is it takes a callback and returns true if any of the calls to the function that's passed in return true. Otherwise, it just returns false. So we are going to be looping over this array, and every element is one of the vertices, which is a string. So we're taking in a vertex, and then we are going to see if the target is the same as the vertex. Then, of course, we want to return true, which will then return true for one call or one of the elements, immediately returning true for this dot sum. So all of this will evaluate to true. So we are going to be returning true inside this does path exist. So for example, A to B, we want to return true. Of course, we're going to say A, yes, it exists, return dot sum, looping over all of these. B, A, does B equal the passed in target? Yes. Thus, we're going to be returning true for this callback, returning true for sum, and then returning true for the function. Great. So otherwise, if that's not the target, we want to keep searching, right? So if none of these vertices inside this array are the target, then we want to check also the value, the array elements at that position in the graph. So for example, if we're looping over B, if we're going to B, and like for the example of A to D, right? So if we're at B here, go to B, B is not the target. Okay, so then let's go to B and loop over its vertices. So we want to say, this is where we're actually going to do a recursive call here. So does path exist, passing in the same graph, not the same starting value, it's going to be the vertex, because the vertex will be like C in this case. C is going to be the new starting value. And the same target. Now, if we just run this function, it's going to return something, true or false, but we're not doing anything with that return value. So in recursion, you always want to make sure that you're doing something with return value. So we want to actually return the truthy or falsy value of that call, and then that will return true or false inside here, which will then waterfall down to, or bubble up to, the original call. So the other thing that we can do as an optimization here is we want to check and see if we have visited something before. So like in the case of D here, well, basically if we visit B once, we want to check and make sure if we visited it before. So we're going to create a new set. So there's a couple things going on here. A new set is an iterable. Basically, it's a class. It's an iterable that has these different methods on it that we can add things to a set. We can check and see if something is in a set. We can do a few different things. You can look it up on MDN. What we are also doing here is we're using ES6 syntax to set a default value for something. So visited, if it already exists, then we'll pass it in. Like if we're passing it in, it will be the passed in value. Otherwise, we're initializing a new set here. So we want to, after we check and see if this actually is a position in this graph, we want to make sure that we check or we want to add this to our set. So graph visited dot add start, because we're visiting this start vertex. And then before we check this, then we want to say if not visited dot is it visited dot has? I think it's visited dot has. Let's see. I think it's dot has. Yeah. Vertex. Great. So if it's not, then we want to, return. Sorry, guys. Let's get our syntax correct here. Okay. If we haven't visited it yet, then we want to do this recursive call. Otherwise, just return false. So because if we have already visited it, then we know that it's not true, because if it was true, if it was the target, then we would have already returned true. So if we have visited it already and we didn't return true, then we want to return false immediately instead of doing this recursive call, because that's just a bunch of extra work. Cuts down on time. All right. So at this point, it should be pretty much done and ready to go. Let's test it out in the browser, in the console. We're going to be defining the new function here. Ah, shoot. Let's go back here. Let's see, I think I have it already. Right, so then we are going to use our example here of const graph, and then so does path exist in this graph A with B being the target? True, yes, okay, great. Let's try another one. This one should evaluate to false. And it does. One more. Does path exist? A, D. True. Great. All right, that is it. Graph traversal, more or less. Thank you for watching.